Okay, then going to start share screen. Which one? Should be this one. Okay, and today I hope I can complete NumPy. Okay, and then Wednesday we can start pandas. And if you recall last class at the end, I believe we discussed the dot dot 3 dot. Okay, be careful. Okay, in brackets. Then generally it covers any many colons. Okay, as needed to provide it as a complete indexing tuple. Okay, and a lot of times that serves because it's colon, then it means slicing. Okay, so I believe you all kind of already get the difference between slicing versus indexing. Okay, that's used quite a lot, okay, with NumPy and the pandas later on. Okay, that's the dot slicing and indexing. And for multi-dimensional NumPy arrays, how do we do iteration? So here I gave a pretty simple example. So you like over here, it's regarding, so this B is a two-dimensional array. And also just keep that in mind, okay? So if we take a look, so so here we have, so we have this brackets and the comma, is it? So this is the first dimension, and then we have what? Then we have within it, we have another pair and a comma. So this is the second dimension. And the third dimension is a column. So we are going to loop through this array we want. So by dimension, so first we are going to loop. So we are going to get this 2, and get this 2. And then within it, then we can get like each of the inner brackets. So that's how we come out with this result. And also if you take a close look, so this print, it's indent, as it is indent and the same indentation as this for loop. So this print is within this for block, okay? Because in Python we said it's only indentation for block, not block. So there is no curly brackets for block. Okay, so that's regarding iteration. And you can also flatten the multi-dimensional array. You can just call it flat, okay, the attributes. So this is some trivial things. What next one? It's also kind of important is change NumPy arrays shape. Okay, so there are a couple of ways that we can do. And here we first will see this two method, two function, revel and reshape. So let's take a quick look at the example. So before we start with revel and reshape, so anyway, so array, NumPy arrays reshape, we also going to, some minor thing, it's about some random number generation in NumPy. So here, if you take a look, this first function is called random integer. So this is generated random integer, and you can specify the range. And here, this size is a shape. Okay, so if we take a look at the results, 3 by 4. So you can specify the range with the integer and also the shape. And the second one, it's all from numpy.render, the package. The second one is rand. Okay, for this rand, if you take a look, within it, you just put numbers and followed by comma. So this also means the shape. Okay, so 3 by 4. But this rand generate number between 0 and 1. Okay, And we have another one. If it is called random, okay. And within it, so here you plug in tuple. So this tuple gives you the shape of the array. Okay, so here, and also it's similar as rand, it's between 0 to 1. Okay. So that's regarding random number. And here to just mention, sometimes you may want to use a floor method, then you can go ahead and do something like this. It's pretty straightforward. Okay. And then what next? Let's see the ravel and the reshape. Okay, so first let's take a look at the A. Okay, so array A is 3 by 4. So 3 by 4. So we have 3 rows, and 4 columns. So it's a 2-dimensional, okay. And if you call ravel, so what a ravel did, it returns a flattened array. Okay, so ravel returns a flattened array. If you want to reshape it, so total we have 12 elements. And then if I call the reshape and the 6, 2, then the array, then you will get. So be careful, okay, so here it's return the array, okay, next we will see it's on the array itself. So anyway, so this return another array, okay, with a different shape. So then in this case, if you call a.reshape, it returns a new array with a modified shape. So this time it's 6 by 2, okay. Another one is on A itself. You can also write after class if you output A, then A won't be changed the shape. It's still 3 by 4, okay. But if you call the resize, so resize is on the array itself, then A is changed to 2 by 6. So this just different ways. And when you call reshape, and if you take a look in this example, it has some negative index. Negative index, and previously what we learned is kind of like a count from the end, is it? And here, this negative one, then it just means total elements we have 12, and the first dimension is 3, then it's just 12 divided by 3, then you get 4. So whatever the remaining should be, then it will take. So it didn't specify, so it will do the calculation for you, okay? So sometimes if you say, okay, I just care about the first dimension or the second or the third dimension, of the other I don't care, then you can just use the -1. So just give you flexibility. Okay, and for the ravel, you can also call numpy dot. So NP is we already abbreviated as NP numpy. So you can also call NP dot ravel. Okay, the previous we say the A dot ravel. So both works. And the reshape here shows again, is that. And then if you take a look, A initially is 3 by 4, is it? And then you can call reshape, you can reshape it to 3-dimensional. That's a 2-dimension. Here we got a 3-dimension, is it? That's also fine, because sometimes you may need to change. Then in this case, you see we have, so this is the first dimension, is it? Second dimension is within this second level of brackets. And this is the third dimension, so just whatever left. Okay, that's regarding shape. And then, and over here, this reshape, is it? And it's, be careful here. If we take a close look, this reshape, it's 2-dimensional. Okay, if you take a look at the output, it's kind of like one, no, it's still 2-dimensional. If you take it, because we have 2 levels of square brackets. Okay, so it's just the first dimension, is it? It's just has one item. The second dimension, just whatever left. Okay, so the first dimension, it's like that, but we only have one row, but we have multiple columns. Okay, but it's still two-dimensional because we have a comma for the reshape. And if you take a look at the other one, the reshape, just -1. So this is just one-dimensional. So that's why the output is just one bracket. So there's just some subtle difference. Let's just pay attention, okay? And if you call Rebel, it said it's the same as the reshape, okay? So this is regarding NumPy array. We can modify the shape, okay? Because sometimes we do need that. And what is the next part to cover? It's also kind of important is because even in machine learning, a lot of time you have data set, multiple data set, and then maybe you want to concatenate them together. How do we do that? So for over here, it's just regarding stacking arrays. Okay, but can along different axes, so it depends. So let's take a look. So first, let's take a look. We have two arrays, A and B, okay, and we use some random number as it to generate with the 2x2 shape, okay. And so this is the first array. This is A. And then we have B. This is B, and then we have AB. And then let's see, you wanted to kind of combine these two arrays together. But when you combine these two arrays together, because it's two-dimensional, and then you may want to decide, to determine if you want horizontally or vertically, as it stacking that. Okay, so if you call V stack, that means you want to vertically expand it, combine that. So that's why the result. So this is vertical. So visually, it's also matches, is it? So you make the array kind of deep, is it, in this case? And then if you call H stack, so V is vertical, so this is regarding horizontal. So horizontal combine, is it? Then basically you can see we kind of make the array wider. This is deeper. That so if you want to combine multiple arrays, you can borrow this V stack and H stack, and you can also do column stack. Okay, column stack. But here, if we take a look at the column stack, the A and B is 2x2, is it? Then what the result is? You kind of make it wider. So column stack is also wider, expand horizontally, okay? But we need to be careful is regarding one-dimensional array. So here, A is a one-dimensional, B is also one-dimensional, is it? Okay, with this one-dimensional array, then if you call column stack A and B, and if we take a look at the result, that's interesting, okay? Then it's not a horizontal expanded, it's do the vertical. Okay, so that's just for the column stack, the special case, okay, for one dimensional. If you call column stack, then it will make it deeper and return a two-dimensional array instead. Okay, so that's some subtle difference here. And here regarding one-dimensional array, if you call H stack, it's the result is still 1D. That column stack, the result from 1D to 2D. Okay, that's just some subtle difference. We need to be careful. Okay, and then what's next one? Sometimes we may also use this attribute NumPy dot. that new axis attribute. So it says, what does it do? It does to increase the dimension of existing array, okay, by one more dimension. So sometimes you may want to do that. So let's take a look. Array A is a one-dimensional array, is it one dimension? And if you output the shape, the attribute, you will see it's just one dimensional, okay? Even though it has a comma, is it, but it's just regarding the first dimension, the two items. Okay, and then if you call something regarding this array, is it, and you have the square brackets, within the square brackets, what you put is something like this. You have the new axis, then comma, then colon, colon. So this kind of, previously we learned that this kind of like you do indexing or slicing from the array, is it? But here, the idea is you are going to expand the dimension with this special keyword, a new axis. Okay, new axis. And if we take a look, the result, what it says is, this is the result. The result is a two-dimensional array. Is a two-dimensional array. And this two-dimensional array, because if you take a look, the new axis is on the first dimension. New axis is first dimension. For first dimension, it's just one item. Okay, one item. But for the second dimension, it keeps the original. The original is 2, is it? So the second dimension keeps as original in this case. Okay, so that's why how we come with the 2D array, but the shape is 1, 2. Okay, so this is regarding first dimension. This is regarding second dimension. The number of, so it's 1 by 2. Okay. Okay, so that's new axis, and it's not just you can do anywhere, is it, if you want to expand. Okay, you said, okay, for the first dimension, I want to keep as original, and then for the second dimension, is it, and then I'm going to add a new dimension, but just with 1. So that's why the shape in this case is 2, 1. Is it 2, 1? So that's how you come with kind of like a 2 row then in this case, is it? And the column, you only have 1 column, okay? But it's 2-dimensional, okay? Be careful. And then you can also use this with the column indexing, with column stacking. So you can also use this to do the stacking, is it? So in this case, the second dimension, this is you expand it to the second dimension for this array. Is it? So initially it's what? It's initially it's 2, the shape. And then if we do the colon, then comma, then new axis, so the shape changes to 2, 1. Is it 2, 1? So that's how you come with this 2, 1. So basically, it's flipped from horizontal to vertical. It's the same thing for B, is it? So it's changed to 2, 1. Is that how? That's how you come with 3 and 8 vertically aligned. Then you can column stack. Is it? Then you horizontal expand it. So then the shape completely changes to 2 by 2. Okay, so we can clearly see it's quite flexible. And in this case, you can also use H stack, okay, to do the stacking. So that's regarding that. You can also call row stack. Okay, so after class, if you're interested, you can play around with it. And what is the next one? Try to show us the new axis. A lot of times it's also quite useful. It's try to make use of NumPy broadcasting. So always keep that in mind. Okay, in NumPy it has a broadcasting rule. Previously we learned for the function, is it, and operation, arithmetic operation. The broadcasting rule, that means you don't need so means no loop needed. It's just direct the operation, that, and it will do one by one for the array. Okay, so that's broadcasting rule. So just keep this word in mind, okay, for NumPy. So anyway, so here we have two one-dimensional array. Both are one-dimensional array. Okay, then let's see this XARR new, that we are going to add a new dimension. The new dimension is 1, and the original, the first dimension, we are going to have 1, 2, 3, 4, 5. So yeah, so we converted basic from horizontal one to a vertical one. As then within it you have the comma. So it's a comma determines, okay, how many of the items. So anyway, we have this from one dimension, from horizontal, change it to vertical. Is it? And then let's see. Oh, hold on. Let's also take a look. XAR2 is a it's a one-dimensional array. It has 3 elements in first dimension. Okay, so that's this X array 2. But it's what? It's a it's a one dimension with 3 items, and this one is what? Is 1, 2, 3. So it's 5 by 1 dimension. So it's anyway, it's a 2D, is it 2D, but it's 5 by 1, okay. And then over here, if you take a look, we apply this plus operator. And then we say, okay, this plus the, what does that mean? Even in math, that kind of doesn't make sense. Is it this, when you do a matrix addition, the 2 matrix should be the same shape. Is it? But here, that's not the concept. Okay, here this plus is considered as an operation, arithmetic operation. So what here does is the broadcasting rule. It's broadcasting. Okay, so let's see, what does that mean? The result. If you take a look at the result, you will see, because AR2 is 3 items, 3 elements in that in first axis. It just has that one dimension, is it? And this one is a 5 by 1. Is it 5 by, it's 2 dimension, 5 by 1. And if you take a look, the result is what? Is a 5 by 3. 5 by 3. So basically it's what? It's going to be this one, and plus x2 is 5, 4, 3, is it? So 5, 4, 3. So basically it's going to, each of this item is going to plus 5, plus 5, plus 5, plus 5. Is it first? So that's how we come with this column. So it's a broadcast, is it? So plus 5. So when you do this, it's going to plus the first element to every one of that. Okay, and then it's going to add plus 4. plus 4 is it to get the second column, and then same thing, add plus 3 to the third column. So you can see if you use new axis and the broadcasting rule, you can do quite a number of things, okay? And the next one is pretty similar, so we are not going to cover that. And the splitting, and I don't think we need to use that. And the copies and views is pretty straightforward. So if you want after class, you can take a look of this part, okay? And later on, I don't think in machine learning, we're going to use a lot of that concept. So I'm going to just skip that. But in case if you are interested, you can read those parts, okay? And also here, another concept is slicing an array returns a view of the array. But here, be careful, okay? For the view of array, if you take a look, for view, whenever you update, it's still update your original. Okay, so that's we need to be careful. So array A, what is array A? Oh, here's array A. So anyway, so array A is a 3 by 4. So this is array A, okay? And then if we take a look, what does that mean? That means for the first dimension slicing everything. So including everything, etc. Okay, so that means all 3 rows we needed to include, etc. For the second dimension, we still do slicing, etc. But we slicing from what? From the second one, third one, but not including the last, etc. So we are going to get this 2 out. Get this 2 out, and then, so this is, you're going to assign it to S variable. Then you said, okay, for S, everything. So this is slicing everything. You're going to do what? You said just assign to 10. So once again, this is to every element, so element wise. So 1 by 1, so that you don't need to use a loop to do that. Is it? Then you, if you do this 10, if we take a look, the result, A is the original. So it does change. Okay, so slicing, that means slicing return a view of whatever the array. But whenever you change the view, is it, you also change the original. Okay, so just be careful here. Okay, if you do want to deeper copy here, that you can do that. So you, if you, sometimes you say, I don't want to modify the original, then you can copy it, then do everything on it. Okay, what is the next one we are going to discuss about? It's NumPy advanced indexing. Okay, advanced indexing. So here it lists 3 scenarios. Okay, let's just take a look. The advanced indexing, what does that mean? So here A is a NumPy array, and this NumPy array created. So how about let's post this as a question. This NumPy array created by what? So who still remember? This NumPy array A created by what? Anyone knows? You, if you know, if you answer, you can get some bonus point. Anyone knows the answer?
You mean by what?
Create what?
What do you mean by what?
By what kind of container or data structure or array or whatever? That's what I
You're
mean.
feeding NP array a list. Yeah, a list.
What is this? The NumPy array. What is this?
It's a list inside.
Yeah, it's a list. Okay, yeah, very good. Yeah, you can send your answer to chat. Okay, so then later I'm going, put your complete name so that I can keep track of the name, complete name, so that I can find it in gradebook. So this NumPy is created with a list, Python list. Be careful, okay? It's a Python list. And then let's see, then you do A. And within A, you have brackets, etc. Then within the brackets, you have two kind of list, but with integer number, etc. So what this is, and also has a comma. This is two-dimensional. A is two-dimensional. So when you have a square bracket and comma, it does match the two-dimensional. So this is regarding first dimension. This is regarding second dimension. Is this second? And all integer number and also with square brackets. So this means what? This means you are going to do indexing. Indexing, etc. So the first dimension follows 0, 1, 2. Okay, so the first is it's this is the first 0, sub-0, sub-1, sub-2. So anyway, all three of them. And for the second dimension, so let's take a look. Second dimension said, okay, 0. Okay, so for the first one, 0 is 1. For the second one, 0 is 3. And for the third one is 1. So it's 6. So that's how you get an element out. So this is called indexing. Is it? But you use the index value to do indexing. And the NumPy array. And here we said it's Boolean indexing. Is it? Oh, not Boolean. We discuss indexing, and we discuss NumPy arrays advanced indexing. Okay. And what over here, the next one show Boolean indexing. Okay, Boolean. So how that going to work? So here we have an array. It's a one-dimensional array. And if you take a look over here, and if you just do array greater than 50, so this is kind of some conditional check, is it? And previously we also discussed it's broadcasting element-wise for a NumPy array. So you don't need to write a loop to do one by one check. So what this means, you're going to check element by element to see which one is greater than 50. Is it? Okay, then we can see only these two elements greater than 50. Is it? So you can identify these two items. And then what do we want to do? We want to know which two. Is it? Then you just do A with the indexing, because this will return false, false, true, false, true. Is it? So your result, A greater than this condition check, the result will have FFT. Is it? And then you do A something like this. Is it? And it matches its dimension. So then for false, then it won't take, it will just filter out all of the true value. Okay, so then that's why we call this as Boolean indexing. So it's quite useful for you to do filtering, searching. Is it just a single statement? Is it with some operation? You don't need to do the loops. Okay, and then next, let's see this one. So we have this array. Is it? For this array, the first condition, what it does is the element module 40 going to be remainder is 0, so can be divided by 40. Is it? You want to know, okay, so this is false, this is true, true, false, false. So we have this 2. So you can, so for this part, and then this is a Boolean indexing. So you can get out of this 2 out, 40 and 80. Get this 2 item out. And then you said, okay, I'm going to do quadratic. Okay, this once again is broadcasting rule. Casting rule. So element by that's how you come with this result. So you can see it's very powerful, is it? When we do numeric calculation with NumPy, you don't need to do 1 by 1. It's pretty fast. Okay, and then next is for some of the operation, you may want to do the operation along certain axes. Okay, along certain axes. So how do we do? And if you have index -1 as the axis number, that means it's the last axis. Okay, so we already kind of touched that concept. Okay, so then let's take a look. So we have this B array. So it's a 3 by 2 array. Okay, B, and then you call B dot sum. So we want to do summation, is it? And here we specify as -1, or you can do axis like equals 0 or 1 something. Is it here? We just didn't do. We just directly assign -1. That means the last axis. Okay, the last axis is which is column. Is it? So this means you are going to do what? You are going to do the summation. You're going to do the summation by the column. Okay. So you're going to sum along the column. Okay, along so vertically do the summation. Is it? So that's what sum row, this B dot sum -1 means. And then over here, okay, you say for this operation, if it can be divided by 10, is that? So if the remainder is 0, I'm going to take out those. I'm going to take out. Oh, I'm sorry. Here I totally messed up. So it's -1. Okay, so maybe let me write it this. So 5, 4, 5, 16, 4. So we have this shape of B. Is this shape of? So we are going to do sum. So basically here axis is 1. Is it? Or axis is 0. So that's so axis 0. Then you are going to do the summation along this. And if axis is 1, that means you are going to do summation. You're going to sum the column. Okay, sum column. So it's row by row, row by row. Okay, row by row. So that's what we are going to do the sum here. So sum. We are going to do the sum of the column, but row by row. And then we want to find out to divide by 10, and remainder is 0. So this one is going to be 10. This is going to be 20, and this is 9. So definitely only the first one and the third one, the last one, going to be divisible. Is it? So that's how we get this output. Okay, so this -1 anyway, its axis is 1. So you can also provide the argument. is it explicit argument, or you can just pass in that value. And like over here, if you do some 0, that's a different story, is it? And you can also output, okay. Okay, so that's regarding advanced indexing, okay. And we already see the example regarding broadcasting rule, okay. So let's just keep that in mind. And we have a little bit of more in NumPy regarding indexing. It's called fancy indexing or index tricks, okay. So let's just be careful. So here you call that a range generator, the range number between 0 to 31, and then you call the reshape, okay. Reshape it as 2-dimensional, so 8 by 4. Okay, and regarding this array, then I said, okay, I provide something like this. Okay, so within this brackets, you have something looks like this. Okay. We have something. We have the brackets. Is it? We have the bracket. So this it means what? This is regarding first dimension anyway. So x is basically 0. Okay, for x is 0, what you're going to do? You're going to do indexing, because there is no colon, no dot, dot, dot. Is it triple dots? So that purely just means indexing, but only indexing for what? For first dimension. The first dimension, you're going to get the second one, and then 0, 1, 2, 3, 4, 5. Then this one, the 5th one, and the 7th one, and the last is this one. No. Sorry, got it wrong. So the last one is going to be the 3rd one, is it? So basically, you can also see it's go to the last. It's also kind of rearranged after the indexing, okay? And then if you take a further, is it? So regarding first dimension, do indexing. And the second dimension also do indexing. Is it? So first dimension, we already get the result. Second dimension, it's go, okay, 0. Is it? We have 0. The first, for the first dimension, we get 1. So we get this 4, 5, 3. Is it? And then regarding the second dimension, you're going to get this 0. So you're going to get this item out. And then for the next one, it's 5th. So we already have that. Is it? And then for the second dimension, you're going to get the 3rd one. So that's how you come with 23. The next one, okay, it's the 8th. And for the second dimension, it's you got to the second one. So 29. That's how we get to 29. And the last one is the last one. And for the indexing, it's the 3rd. So it's 10. It's 10. Is it? So this gives you the indexing along both dimensions. Okay. And if you take a further look, then for this one, so basically over here, you already have what we previously saw the result. Is it? We get a 4 by 4 array basically. And then on that array, for the first dimension, you are going to do slicing. So basically, every one I'm going to include. And then for second dimension, I'm going to get what? To do the indexing. To do the indexing. That's how you come with the result, looks like that. Because sometimes if you take a look, if you correctly use the slicing and the indexing, you can rearrange the array. Is it? So basically here, if you take the result, still 4 by 4, but it's just you rearranged. Okay. So that's regarding this fancy indexing. And then next, let's take a look this one. This A, if you take a look, so this arrange will generate number between 0 to 11, is it? And then you quadratic. Is it? So that's how we come with this result. Okay. And I is a NumPy array, it's one dimension. So this is I. Is it? And then you do A sub I. So I itself is a NumPy array. NumPy array, but it's integer. Integer, is it? So then in this case, it serves as indexing. Indexing. So it's just going to pick out the corresponding item. Okay. So the second item and the second item again, is it? And then the second, the third, the fourth. The fourth item go to here, and then the ninth. Okay, I'm not sure the ninth may be here is considered the ninth. Is it? And then the sixth, the sixth. So just pick out some items using this array. And then next, let's see this one. The A itself is one dimensional. But let's take a look at this J. J is a what? It's a two-dimensional, 2 by 2 integer array. Is it? You plug in a integer 2 by 2 array to a one-dimensional array. So what does that mean? So that's why we call it fancy indexing. So that means your result is also going to be a 2 by 2. So you pick an item and you rearrange as this shape. Okay. So you can see it's quite flexible. And let's take a look at this one. It's interesting, is that for coloring a lot of time when we deal with, so coloring is between 0 to 255. Okay, so that's why we call it a palette, is it? And it's a two-dimensional array in this case, giving you certain color number. So it's RGB, it's an RGB, okay. Red component, green component, blue component. Depends on the integer number, then you get a different color, okay. So anyway, so this is a palette can be represented as a two-dimensional array. And here is the image you define, is it? And this is not the real image yet. Is it? It's just from the palette, you want to take the color pixel, is it kind of concept like that? Is it? Okay, so the picture is a two-dimensional picture, is it? It's a 2 by 4, is it? So 2 by 4, so totally 8 pixels kind of, is it? And then for each pixel, it needs to have a color. So that color should be one of this color defined. Is it one of the row defined by this palette? Is it? So how do we get that result? Oh, yes, let's see. So then you do palette and plug in with this image. Is it? With this image, yeah, it does match. Is it? If you take a look, this is a 3-dimensional array. Now, is it? But the first dimension is 2. 2. Is it? Second dimension. Second dimension is what? Is 4. Is 4. And third dimension is 3. The third dimension basically is represent pixel color, as a pixel color. So then you can use this to generate a picture. Okay, so that's regarding this fancy indexing. Okay, and the next we kind of have so this array. This is a 2-dimensional array, is it? And I is also 2-dimensional integer array. Then you do A sub I. So this kind of, you rearrange that and change the shape. So you come up with a new array here. And this new array basically is three-dimensional now. This region, this concept is a little bit of similar like the previous one. So you get a new three-dimensional. So a lot of time we do need to use this kind of skills. Okay. So anyway, so this is similar as that palette, and the same thing is it not just plug in with an integer array. Okay, not just do indexing. We can also do slicing plus indexing. Is it? And then you can get a new array with the known numbers. Is it? With the known numbers and rearrange the shape. Okay, and it's quite useful. And but be careful here. If you do a and then comma, then in this case, these two array must, the shape must be the same. Okay, otherwise it won't work. Okay, so just be careful. If you have both two dimensions, okay, both two dimensions. Okay, and I think, one last thing I run out of time to cover. So anyway, so Wednesday I'm going to cover this. Okay, so this is the last thing in this NumPy part we run out of time to cover. Okay, so that's all for today. Any questions before we dismiss today's class?